This video is for 3.3 notes, and we are going to be discussing dividing mixed numbers, and we'll be using that multiplicative inverse. So a few words we need to talk about are the words simplify. Another word you might hear is the word reduce. If you reduce a number or you simplifying it, right, you're taking it to its lowest terms. You're making it simpler, reducing the big numbers. So as we reduce, we take it to its lowest form. So instead of saying, right, 6 over 12, there's a number that can go into 6 and 12, which is 6. So we can divide them both by 6, which ends up being 1/2. Once I'm to 1/2, the only numbers that can go into 1 and 2 is 1. So we know what's in its lowest terms. So it's simplified, reduced, lowest term. It is only divisible by 1. That's its only common factor is 1. So we have these mixed numbers that we're going to be discussing today. So a mixed number is a whole and a fraction together. So for example, if I have 4 whole cakes and 1/2 more, 4 and half, that's a mixed number. Whole number, fraction, mixed together, 4 and 1/2. And an improper fraction is when we have a larger, that does not say numerator, larger numerator. So lots of times when we think of fractions, we think of something like 3 over 7, 3/7. But when you have a larger number as the numerator, like 7 over 3, that is improper, right? Not. Proper means that's like the right, correct way. So it's not the right way that we usually think about fractions. So we can work with numbers like that. But when we're done with the problem, we don't like to leave them like that because it doesn't really tell us everything we need to know about that number. So as we're changing from mixed to improper, we've got 3 steps here. So here we have 4 and 3/7, 4 wholes and 3 out of 7 pieces. So our first step is to do the denominator times the whole. So this 7 tells me that there are 7 in each of these. The whole tells me that I have 4. So 7, 7, 7, 7, 7 4 times. So the first thing I do is multiply. I'm going to use a red instead of gray. So we're going to multiply 4 times 7. So right here, I have 28 pieces. And then I'm adding on the other ones, 28, 29, 30, 31. So second step, add the numerator. So we multiply, add, and now I have 31 pieces. If I count up all the pieces, there's 31. And then our denominator stays the same because it still has 7 pieces in one whole thing. So I now have 31 over 7. As these are equal, they mean the same thing. If I wanted to go backwards, 7 goes into 31 4 whole times, which is 28. 3 left over out of 7. You can see every time the denominator stays the same. So as we're doing step-by-step mixed numbers, it's very similar to just dividing fractions. However, there are a couple extra steps here. So we've got this problem we are working with. First, let's write down the problem. Make sure we have this here. So it's already written down for you. So step 2 is we have to change these from mixed to improper. We can't just divide across because if you do that, you start leaving out pieces and you've got to change them to improper. So we know how many pieces we're dealing with and we include all of the pieces into the groups. So change it to improper. So we do 3 times 5 is 15 plus 3 more is 18 over 5. Denominator stays the same. I'm still working with the division problem. 5 times 1 is 5 plus 1 is 6 over 5. So here's my new problem. Now we're going to use the multiplicative inverse to flip that. So if you remember, right, it cancels, kind of like it's canceling it out. It all equals 1. It's the same thing. So that multiplicative inverse, we're going to copy this first one, keep it the same. This is what we have. Dot, we're multiplying here. And the inverse flips that into 5/6. Now we can cross-reduce if possible, make our numbers smaller and easier to work with. So I notice these 5s have a common factor of 5. 5 divided by 5 is 1. 5 divided by 5 is 1. Always have to use a numerator and a denominator. Then I can see that 6 and 18 have a common denominator of 6. 6 goes into 6 one time, and 6 goes into 18 3 times. So our next step is to multiply the numerators. I'm going to rewrite that problem. So we had 3/1 times 1/1. So if I multiply my numerators, 3 times 1 is 3. Multiply my denominators, 1 times 1 is 1. And I'm left with an improper fraction here, 3/1. I need to simplify. 3 divided by 1 is 3. So when I have 3 3/5 and I'm dividing it to 1 1/5 groups, I can make exactly 3 in every group. So go ahead and make sure you finish up your notes here, get all of the steps written down and examples, and